Hello again. Today I'm going to talk about Treponema pallidum and Cyphilis, which is a terrible disease. Treponema pallidum is the causative agent of syphilis, and it was discovered by Schaudian and Hoffmann in 1905. They were respectively a zoologist and a dermatologist. This bacterium, was found in inguinal lymph nodes of syphilitic patients. How is its structure? Well, it is a thin, delicate, helically coiled and corkscrew-shaped organism. It is 10 to 14 micrometers long and 0.1 to 0.2 micrometers wide. It has got 8 to 24 sharp and angular spirals at regular intervals of about 1 micrometer. It is actively motile, and under dark field microscopy it appears to be clear, really clear, almost white. That's why it's called Treponema pallidum. And it consists of rapid rotation around its long axis, slow forward and backward motions, and compression, expansion, bending or flexing, and burrowing movements. Secondary curves appear and disappear in succession, but primary spirals remained unchanged. Treponema pallidum has got a central periplasmatic cylinder, a cytoplasmatic membrane, a thin peptidoglycan layer, which is the cell wall, an outer membrane layer, and a periplasmatic flagella called endoflagella. The bacterium differs from the most part of gram-negative bacteria because of two major aspects. First of all, it lacks lipopolysaccharide membrane proteins, and then, second of all, it has got integral membrane proteins and lipoproteins. Another important thing is that it has got host surface proteins that prevents the antibodies from binding the antigens, so from binding the bacterium and then kill it. Treponema pallidum is rapidly inactivated by mild heat, drying, and most disinfectants. Treponema pallidum is microaerophilic. It means that it survives better without the presence of oxygen, but it's also able to tolerate little amounts of oxygens. Treponema pallidum, in fact, doesn't have the enzymes that are essential for giving the capacity of tolerate the presence of oxygen, which are, for example, superoxido, dismutase, catalase, and peroxidase. It also lacks many biosynthetic pathways, so it's almost completely dependent on host molecules for survival. The Treponema pallidum is transmitted from direct sexual contact or from mother to fetus. There is 30% chance of acquiring disease after single exposure to the infected partner, but the transmission is dependent upon the dose, upon the stage also of the disease. The infected dose is about 57 organisms, and the incubation is really long, it's about 9 to 90 days. The disease manifests when bacteria reaches a number of about 100 millions per gram of tissue. As soon as the bacterium enters the organism, the host organism, there is a multiplication at the site of entry, then the invasion through mucous membrane and epithelium, then the dissemination to regional lymph nodes, the translocation to circulation, and localized or generalized inflammatory response. The diagnosis is essentially made by the direct examination of exudates from primary, secondary, and also early congenital syphilis lesions. So now let's change the subject. I would like to tell you something, what are the general features of Enterobacteriaceae. And from the next lesson, we'll start to speak about specific bacteria belonging to this family. In this family, there are bacteria who are commonly present in large intestine, and they are non-sporing, non-acid fast, and they are mostly gram-negative bacilli. These bacteria some of them are non-pathogenic, a few are highly pathogenic, and some commensals turn out to be pathogenic in specific situations. All Enterobacteriaceae are gram-negative rods. They ferment glucose with acid production. They reduce nitrates into nitrites, and they are oxidase negative. They are facultative anaerobic. They are motile except Shigella and Klebsiella. They are non-capsuled except Klebsiella, and they grow on bile containing media. These plates that are normally used in laboratory are called McConkey agar. Enterobacteriaceae are divided into great groups called lactose fermenters and non-lactose fermenters. In the lactose fermenters, we have, for example, Escherichia coli, Klebsiella, Enterobacter. In the non-lactose fermenter, we have Salmonella, Shigella, Yersinia, and others. The highly pathogenic Enterobacteriaceae are, for example, Salmonella and Shigella. They all are lactose non-fermenters, and they produce colorless colonies on McConkey agar. Next lesson, we'll start speaking about specific bacteria belonging to this family. So see you then. Bye!